Hello, everyone. Happy Monday. Welcome back from your April break. Hope you all stayed safe and healthy. Did something fun, got outside a little bit, and relaxed a little bit. So what we're going to do today is talk about one of my all-time favorite shapes, and that is the rhombus. So I thought it wouldn't be fair for me to start this section off without telling you guys an absolutely hysterical joke. So why was the math teacher late for class? He took the rhombus. But get like wrong bus, rhombus. There you go. There's the kind of humor you guys have been missing. All right, so that's the game plan for today. So speaking of this shape, rhombus. Oh, you guys want to see another cool thing? Everybody, 1 second. I don't know if I showed you guys him yet. This is the puppy we just adopted. His name is Ramsey. He's about 3 months old right now. Yeah, so that's been keeping us busy. All right, bye, Ramsey. All right, let's back to the rhombus. So what we would normally do if we were actually in class right now is we would give you guys different cutouts of rhombuses, different sizes, different shapes, and kind of have you guys investigate some properties or characteristics about this shape. Naturally, since we can't do that, what I'd like you guys to do is just look at that shape for a second, pause this video if you can, and just try to decide, what makes a rhombus that shape. I've heard it sometimes called, a slanted looking square. I've heard some people call them diamonds. But what makes this different than some of the other shapes we had talked about last week before break? Okay, so just to go over a couple things. So we have a definition of a rhombus and then some properties associated with it as well. So the actual definition of a rhombus is that it is a parallelogram with 4 congruent sides. Okay, so there's some important things I want to kind of talk to you guys about here. So first of all, this is a type of parallelogram. Okay, so parallelogram is a very generic type of quadrilateral that has 2 pairs of parallel sides, right? So any shape that has that is considered a parallelogram. This one just gets a little more specific by saying, all right, it is a parallelogram that just also happens to have 4 congruent sides. Okay, the difference here, guys, between this and a square, right, because the square also has 4 congruent sides, is that the rhombus doesn't have 4 congruent angles. So that's the key difference there. Okay, so rhombus, parallelogram with 4 congruent sides. All right, so then some properties associated with that. First of all, this one is true on all parallelograms, but I wanted to reiterate it. So this rhombus has opposite angles that are congruent. Okay, so if I went and drew on this for you guys to show you that, so that means, remember, opposite means across the shape. So I would say that this angle here and this angle here are congruent, and then the top one and my bottom one are congruent to each other. Okay, again, that's one that's true of all parallelograms. Okay, now more specifically to the rhombus itself, its diagonals bisect each other. Okay, diagonals bisect each other. What that means is, all right, well, if they bisect each other, okay, this one gets bisected, and this side over here also gets bisected. All right. Its diagonals are perpendicular. Okay, so the diagonals here, these lines going through the shape, intersect at a right angle, and its diagonals also bisect the angles. Okay, so that means here is if I look at this diagonal that right now is going horizontally on our diagram, okay, this diagonal is bisecting the 2 angles of that rhombus. So to get a little more specific, we can also now say that, let's say I would say angle 1 and angle 2 would be congruent to each other, right? Because that overall angle over here, this one gets bisected, which makes these 2 congruent, okay? And if I was label these ones 3 and 4, those ones, that angle over here also got bisected, meaning angle 3 and angle 4 would be congruent to each other. And the same thing happens on the other diagonal as well, okay? So this angle down here is being bisected, so the 2 halves, these 2 different parts would be congruent to each other, and same thing up there, okay? And if you guys didn't know this before, just a quick note, I'm speaking of this diagonal. That's a segment that connects 2 non-consecutive vertices. Okay, you can see that happening in this shape. So this line here okay, is connecting two non-consecutive vertices. Okay, so non-consecutive just means not next to each other. Remember, vertices are the angles over here of my shape. Okay, so two angles that are not next to each other. So that's why this line's connected non-consecutive vertices. That's considered diagonal. This line here is connecting non-consecutive vertices. So that's also considered diagonal. And that's what these three properties here are associated with. Okay, so let's go through a couple examples. What I want to do with you guys is talk to you about the example, what we're trying to find, and also we're going to apply one of these properties in our problem. Let's talk about what property that would have to be. Okay, so here we're just solving for x. So I'm noticing that we're given information about the measurement of these two different angles here. Okay, so we got to figure out what is the relationship between these two angles. Now, if they were opposite angles, they'd be congruent to each other. If I had information, let's say, about this angle here and this angle here, well, we know in a rhombus, the diagonal bisects the angles. So those would be congruent to each other. But that's not the connection we can make between these two angles. Instead, what's pretty cool here, guys, is I want you to focus on the triangle that's being made inside that shape. Okay? We know that all the angles inside a triangle have to add to 180. So in order to be able to do that, we have to think about what do we know about this angle right here? And this is where our property is going to come into play. Because this property that states that the diagonals are perpendicular is what we're going to use. Because since this is the spot where my two diagonals are intersecting, if they are perpendicular, that means that they have to intersect at a right angle. So I'm going to go ahead and just erase this. Oh, wrong one. Erase that really quick, just so it's not too messy. And we'll put in my right angle mark. Okay. So now we can go ahead and set up an equation having all of these add to 180. So we'll go ahead and write down, all right, well, 3x plus 6. Ooh. Plus 8x plus 7 plus 90, which is that right angle, has to give us a sum of 180 degrees. Okay, now let's just go ahead, guys, and let's solve that equation out. So what I did was I actually subtracted this 90 from both sides. Because what we can say, guys, is if this one's 90, you know these two angles here would have to also have a sum of 90. Because that 90 plus this 90 we already know would give us that total of 180. Okay, so I then wrote 3x plus 6 plus 8x plus 7 equals 90. Okay, and I combine the terms from there. So I got 11x, right, because that's 3x plus 8x, plus 13 equals 90. And I'm going to solve my equation from there. So let's subtract this 13 from both sides. And I end up with 11x equals 77. Okay, I want to get x by itself. So let's divide both sides by 11. And we get x equals 7. Okay, so the first one, guys. Again, the property used here was that the diagonals are perpendicular. And that's how we came up with that. Okay. Next one, find the value of x in the rhombus. All right, so this is actually, I kind of hinted to this in the last example. Okay, because I'm looking at it and I have information about this angle and this angle here. Well, one of our properties states that the diagonals bisect the angles. So that tells us then that these two parts of this angle are congruent because that one had to have been bisected. So all I do here is let's set these angles, these measurements equal to one another. So we're going to say 2x plus 39 equals 6x minus 9. Oop, that's a 9, clearly. Okay, and let's solve from there. So I'm going to subtract 2x from both sides to get my x term on the same side, the equal sign. So we get 39 equals 4x minus 9. Let's add 9 to both sides and get 48 equals 4x. Divide both sides by 4, and then x is going to equal 12. There you go. Again, guys, what we did here was we first looked at our list. Okay, I thought about these different properties and thought to myself, all right, which of these can we apply to help us solve for X in that situation? And based on what was given to us, based on where those measurements were located, that's why we knew to use the fact that our diagonals bisect the angles. Okay, next one's my favorite. All right, so it says find the length of the diagonals of the following rhombus. All right, this is a fun one. So we're looking at this and I see, all right, so this 15 meters is the length of side BC. Okay, so that's not a diagonal, that's the side length. What we could say, not that we need to right here, is remember, since it's a rhombus, I would know all four sides would all have a length of 15, because that's the definition of a rhombus, it has four congruent sides. And I know this one part of our diagonal is 12. Well, we know the diagonals get bisected, so I could also say that this part over here is 12, which means our entire diagonal AC is going to be, well, think about the segment addition postulate. This part here is 12, this part here is 12, 12 plus 12 gives me a total diagonal length of 24 meters. Okay, now, how can we figure out the length of diagonal BD? Because that's what we don't know yet. We're not sure what BD is going to be. Okay, but again, I want you to kind of focus, like that first example we did, on that triangle. And let's look at what's happening on this triangle right here. And think back to that first example. We know our diagonals are perpendicular, which tells us we have a right triangle. Okay, so I know two sides on this right triangle, and we don't know that missing third side. So I'm going to go ahead and put an X there. Now I want you guys to think way back to chapter 8. We discussed a very famous theorem you can use to find the missing length on a right triangle. Come on, shout it out. I want to hear you guys say it. All right, I think I heard someone over there screaming. It's the Pythagorean theorem, and that's exactly it. We're going to use Pythagorean theorem here to figure out what, in this case, the length of BE is going to be. Because once we know what BE is, okay, we're going to double that to find the length of the entire diagonal. Okay, so again, Pythagorean theorem is C squared equals A squared plus B squared. C has to represent what? That's right, C represents the hypotenuse. So we're going to set this up by saying, okay, 15 squared, because that's the one that's opposite from that right angle, has to equal x squared plus 12 squared. Okay, 15 squared is 225. And that's going to equal x squared plus 144. Let's solve this equation for x now. So I'm going to subtract this 144 from both sides. When we do that, we get 81 equals x squared. And then how do we undo squaring something? The opposite of squaring something is to square root it. So we're going to square root both sides and get 9 equals x. Okay, but now 9 is not the length of the diagonal. Okay, 9 was just this half of it, this BE. We have to double that to get the entire length of BD, which would be 18. Okay. Now, what's going to happen here, guys, is after you finish this lesson, you're going to have to go ahead and do a lesson check on Google Forms. Unfortunately, for an example like this, there's no way for me to get you to input two different responses. I can't get you to say, diagonal 1 is 24, diagonal 2 is 18. So what I'm going to ask you to do is enter the sum of the lengths of the diagonals. Okay, that way it just makes it one number, whereas sum just means to add them. Okay, so in this case, I didn't ask for it here, but let's say I asked, hey, what is the sum of the diagonals? That would just mean once you find both of them, okay, one's 24, one's 18, just add those together. Okay, so the sum in this case, wow, great handwriting, Mr. Russell, is 42. Okay, so like if this was a Google form, I would enter 42 in for our answer because that incorporates the two lengths here. I hope that's not too confusing for you guys. Okay, if I ask for the sum, you're gonna add them together. Okay, what I want you guys to do now is pause this video for a second and try this one on your own. And then when you finish, unpause. We'll go over it quickly, and then I'll talk about what to do next. Okay, go ahead and pause now. All right, welcome back. So what you should get, okay, is our two diagonals. Okay, so D1, I'll call it, is 20. Okay, and we'll call it feet. And then D2, which is our second diagonal, this is the one we had these Pythagorean theorems to find. You should have gotten 48. Okay, and just to go over that again quickly, guys. So I'm looking at this triangle right here. Okay, so I'm going to try to find what the length of this side is right here. So let's use Pythagorean theorem. We're going to say 26 squared is going to equal 10 squared plus x squared. Okay, so 26 squared is 676, and that's going to equal 100 plus x squared. We're going to subtract 100 from both sides and get 576. Okay, we're going to do that square. Let's square root both sides. We end up with 24 is x. But again, 24 is just half of the diagonal, just as part of it. We have to multiply that by 2 to get the entire thing, which means our second diagonal is going to be 48. Now, on your Google form, I would ask you, tell me what is the sum of the two diagonals, which means let's go ahead and add these two numbers together, and our sum would be 68. Okay? Again, that's just that formality because of that Google form. All right. Hope you guys are okay. So here's what I got to do next. So I want you guys to go ahead and complete the lesson check. The link to that is on P-Learning. Okay, please do your work on a separate piece of paper so you can upload a picture for a couple of them on that form. The other thing, guys, is we're also going to ask you at the very end, how long does this all take you to go from starting this video through completing that lesson check? How much time did that take? And hopefully, we're keeping it manageable for you guys. We're trying to make adjustments as needed. You know, we care about you guys, and we hope you're all doing well. Okay, please ask questions in the discussion board if you have them. But if not, I'll talk to you guys later. Have a good day.